But then some people were using LLMs for entity extraction. And for me, it was like not so natural using this architecture because all the information are already present in the output text. So you don't really need to generate, you just need to find a way to extract these entities from this text. So my idea was kind of combining like the prompting of LLMs with the efficiency of the encoders. So yeah, it started like this.
Hi everybody, I'm George, here with our founding researcher, Urchade Zaratiana, who we kindly call Uzi. How are you doing today, Uzi? Thanks for sitting down with me.
Yeah, thank you, George. And also thank you for calling me. You are the one that coined the term Uzi. So,
yeah, it's a great nickname. It's a great nickname.
I love it.
So tell everybody about yourself and what you do here at Fastino.
Yeah, so I've joined Fastino like almost exactly 2 years ago now. So yeah, I'm responsible for leading the small language model architecture here at Fastino. And yeah, responsible for all the GLiNER family of models.
Yeah, I remember fondly when you joined us, or when we first met, you were finishing your PhD in Paris. And then GLiNER came into being very quickly after you joined. Tell us about GLiNER and your kind of bold bet on small models taking on like larger encoder-based models like GPT.
Yeah, so at the time, like there was the beginning of the LLM revolution, and LLM, they were really good at performing tasks in 0 shot. So you just need to provide some example and some instruction, and they will give like good output for it. But then some people were using LLMs for entity extraction. And for me, it was like not so natural using this architecture because all the information are already present in the output text. So you don't really need to generate, you just need to find a way to extract these entities from this text. So my idea was kind of combining like the prompting of LLMs with the efficiency of the encoders. So yeah, it started like this.
Rumor was it was just late night during your PhD. You set off a training run, you woke up in the morning and the model was state of the art.
Yeah, exactly. I was really surprised. Like I tried to a bunch of tests to see if the result were actually true or not. So yeah, once I've seen like the result, I try to scale it and yeah, do a lot of evals to kind of make it wrap it as a paper.
And I think 30 million downloads later of GLiNER. Congrats, Uzi. It runs on CPU. It's really easy to fine tune. What do you think is the coolest implementation of GLiNER that you've seen so far?
Yeah, I think that like a lot of NGOs are using GLiNER, for instance, for either for PII or for many humanitarian related tasks. For instance, I've seen recently that UNESCO is using it for guardrails, and yeah, I'm really proud of that. And also many students, like from universities from all around the world, they are basically basing their thesis on GLiNER for some domain-specific extraction tasks. And yeah, I wish I had this kind of model during my master's, actually, because it was really, really hard to kind of have a really powerful model on CPU. And I think GLiNER kind of, make that possible.
Well, now you're enabling the next generation of PhD and master's students. Yeah. Speaking of next generation, GLiNER2 came out in November of last year, passed 1.5 million model downloads a month. What new capabilities are there in GLiNER2 that you made that are upgrades to GLiNER1?
So yeah, when I've seen the success of GLiNER1 and how powerful it was, for me it was like, okay, my thesis was like, okay, any task that you can, any information that already present in an output text, you don't need a generative model to solve the task. For instance, any extraction task. And for me, it was like, okay, but how to perform JSON extraction without generating text? That was like a really challenging question. I tried to think about it like for a month, but then I had a meeting with you and Ash, and you asked me if I had like a research project I wanted to work on. And then, yeah, you really encouraged me to work on that. And yeah, I've started implementing the GLiNER2 architecture here in Palo Alto. So yeah, it started like that. And then I've tried to kind of, add as many tasks as, like primitive tasks like classification, entity extraction, JSON extraction
In
and
one
relation
one forward pass
in
too,
one
especially.
forward pass. So what I want is not only like that the model perform this task, because this was kind of already possible in GLiNER 1 if you play with it. But the idea is to perform all these tasks in one forward pass. Let's say a user can come up and perform, let's say for instance, let's take intent classification. Intent classification usually need to know what is the intent from the input, but also extracting some entities from it. For instance, someone want to reserve to book like a restaurant. So you need to kind of know that the intent is about restaurant booking, but you also want to extract the start date, the end date, and the address. So yeah,
Or the restaurant name.
the restaurant name and
Yeah,
any
as well
other
as their
method.
intent, right?
Yeah, exactly. So with GLiNER 2, you kind of enable that. And you can do it in one forward pass. You don't have to do it in a pipeline way. For instance, you don't need to do like first classification and then extraction. Like usually like model, like traditional model, they are using that. But what we enable is to do both tasks in one model, single forward pass, and you basically keep like GLiNER efficiency.
And combining multiple models into one too, right? So,
Exactly, yeah.
and then in May, when we had a model launch week, we launched the new GLiNER2 PII variant, which a lot of your last GLiNER models have been state of the art. This one was actually beating industry benchmarks. Tell us about GLiNER2 PII, some advancements you made in that model and what made it better.
Yeah. So GLiNER to PII, the idea was that, okay, we have seen that GLiNER is really popular for PII. For instance, NVIDIA make a fine tune of it. So what we wanted to do is to put that capability in GLiNER 2. It was already present in GLiNER 1, but in GLiNER 2 now. And also combining our internal data generation agent to generate high quality synthetic data.
So Pioneer was used pretty heavily in the post-training data.
Yeah, we use Pioneer for that. So we took like our base pre-trained GLiNER, and then we use Pioneer data generation agent to generate data for synthetic data. So it was basically like just describing the text, like I want a PII model with many entity types and these languages, and generate data, and it was doing like everything.
So Uzi, the original GLiNER model, for people who don't really know the difference between an encoder and a decoder, which models like GPT are using, architecture that it's using, tell us a little bit more about how GLiNER uses an encoder and how it's different from a traditional decoder.
Okay, so traditional language model, they are using this autoregressive paradigm. So basically what it does is that given a prefix, like a prompt, it is generating the continuation of the prefix token by token. So you kind of need multiple forward pass over the model to get your final output. This is different with encoder architecture. So in encoder, you encode in one forward pass everything, and then you can perform additional like decoding or post processing to get your output. So which makes it really efficient because you don't do like additional pass into the transformer, which takes the most computation. For instance, the early encoders architecture are BERT, which has been trained using mask language modeling. Basically, instead of like training it to generate the next token, it was trained to infill the mask inside the text. For instance, they will mask out some words in the input, and then they train a model to recover the masked word. And that's with that kind of task, that kind of supervision, the model is kind of learning the structure of language in a bidirectional way. So yeah, our architecture, like GLiNER, is based on that kind of BERT Lake pre-training.
That's great. And let's talk about another one of the models that were launched during the model launch week. Congratulations, Uzi. I heard GLiGuard got accepted into Culm, which is in October here in San Francisco. Tell us about GLiGuard as a guardrail model and why LLM guardrails are important.
Yeah, so we are in an era that like all the internet is flooded with AI content, and many people try to use this LLM for malicious like application. So the goal of GLiGuard is kind of, prevent that, to add like this additional layer to LLM output to prevent either bad prompt and bad response. So yeah, when looking at the architecture and the available like industrial application for guardrail, like these people are kind of treating multiple guardrail tasks as a separate things, or as like a JSON like extraction. So they need to generate text to kind of either classify the prompt safety, the type of harm, the category of the harm, and also the category of the response. So this is like a really slow process. So when looking at GLiNER 2, like in GLiNER 2, we have developed the architecture in such a way that you can combine multiple tasks in one forward pass. So it was kind of like a natural way of usage of GLiNER 2.
So while PII is to help on data privacy, the guardrail model is probably more about security. So whether I'm an agent, calling a model locally, or an enterprise, passing a lot of traffic through LLM in the cloud, GLiGuard can help protect the LLM from prompt injections or other like harmful attacks, I guess. Is that right? Yeah.
And that is, I think, our main motivation to make a single model for both PII and guardrail. So now with GLiGuard PII, you can, like in parallel, given a query, you can extract the private information for it, and also classify if the input is safe or unsafe, or the output of the language model. Because sometimes you also want to redact, for instance, like for application like retrieval augmented generation like RAG, sometimes you want to like output some response to an user, but you don't want the information to be visible. So you want to redact some information. So with GLiGuard, you can do that. You can flag the response, but also mask the private information from it.
So just like GLiNER 2 is combining extraction and classification into a single model, GLiGuard PII was combining PII extraction and LLM guardrails into a single model. Yeah, exactly. And they're all available on Hugging Face.
Everything open source for anyone to use, every researcher, student to experiment with it.
So the new release that we're really excited about, and we brainstormed again in Palo Alto together, GLiNER 2.5. So tell us about some of the architectural enhancements. I think one of the big ones now is for longer span extraction. So maybe tell us about some of the limitations of the previous GLiNER models and now what's going to be possible with GLiNER 2.5.
Yeah, thank you for the question. So yeah, GLiNER 2 is like really powerful architecture. You can use many tasks on it, but there are some certain limitations that kind of prevent people from using it for different tasks. For instance, one limitation is that when doing extraction, like entity extraction, the length of entities are bounded to a certain level. So for now, the GLiNER 2 model can handle up to entities up to 12 words. So for instance, there are some countries where you have like very long address, like the model would not be able to extract that kind of information.
Or for JSON extraction as an example too as well.
Yeah, exactly. For instance, you want to extract some sentence directly. For instance, you want to extract like claim extraction from the text. Like there are many applications that are not possible with the current GLiNER 2 architecture. So yeah, one of the features of GLiNER 2.5 is that now the length of entity span are not bounded anymore. So we are using a new technique to kind of extract any length span from text.
And in the same vein, you're increasing the context length of input in GLiNER 2.5, right? Whereas people were manually batching before, you're now introducing live batching to GLiNER 2.5.
Yeah. This is also a nice addition to GLiNER 2.5 because many people want to use GLiNER 2 for long context extraction. So now in GLiNER 5, we have some module to make it easier for people to do that. And like the context length of GLiNER is not capped, so people can extract any length of any input length, but usually like the performance tend to degrade for very long context. So we have these additional tools that makes prediction more reliable.
And then new updates to span attribution and sentiment. Tell us about those, Uzi.
Yeah, so if we go back to GLiNER 2, currently we can, one can perform any classification task with it, but it will be at the sentence level or paragraph level. But some people from a large financial media outlet was asking me about, is it possible to perform text classification but at a span level? For instance,
so on a single word or a single term or a name, for example.
Yeah, exactly. For instance, if you want to you want to extract company names from a text, but they also want to classify is the article talk about this company positively, negatively, or neutral, classifying the sentiment of the span.
So it's much more fine-grained classification.
Exactly, this is a fine-grained classification, and we kind of in GLiNER 2.5 we are adding this feature. You can not only classify a sentence and input text, but you can classify at the span level. You can specify, okay, I want to extract products. For instance, you want to analyze news about products, fund. It will extract those entities, but then also classify if they are the article is talking about them positively or negatively. And you can also expand that to any other task. For instance, you want to extract opinion about people, and
Okay, and in the same vein, you're introducing joint entity extraction for constrained graph decoding. So being able to build knowledge graphs. Can you tell us about that?
Yeah. So in the GLiNER 2 at the current stage, you can extract entity and relation from text. But what this feature adds is basically a constraint decoding to make sure that your input respect some schema. For instance, from a use case to another, what represents a relation can be different. So in this case, for instance, you want to extract relation between a person and a company with the relation work for, you can constrain the entity types to make your graph coherent and so that your knowledge graph is clean, I will say.
So it's more accurate, relational entity extraction, basically, and building the relationships between them to help with
exactly.
Knowledge graph construction.
And this work was kind of really inspired from one of my paper I wrote during my PhD. It is called Enrico. And what this paper does is exactly that. It's a globally constrained entity and relation extraction decoding. But it's just applying it to GLiNER. So I'm really happy with that.
And another feature that you wanted to release this week too, Uzi, is constrained classification. Can you tell us about that?
Yeah, this is in the same line as joint entity and relation extraction. Yeah, it is the fact that within GLiNER, you can combine multiple classification tasks. But the problem is that all the predictions for each task, they are kind of independent from each other. And this layer is kind of making sure that the output is coherent. For instance, some people have noticed that in the guardrail model, sometimes the model will predict the prompt as safe, but the jailbreak classification will say, oh, maybe there is instruction override. So this decoding is kind of making all the prediction informed from each other and applying some mathematical solver to get the best output of it.
And the last one on GLiNER 2.5, I think your last PII models have all been state-of-the-art, but now you're introducing a new PII policy engine to improve performance. Can you tell us about that?
Yeah, one of the biggest applications of GLiNER is actually PII extraction. But currently, people are using either their own script or external libraries to make it work, to redact the text. So what we are adding with this new feature is that we have our specialized harness for GLiNER 2 to make it to maximize the performance, I will say, so that we have a model that has been specifically trained to optimize this inference engine, so that people can add rules to their PII extraction and will they redact the text. So it's just a customization layer.
And all those toolings are going to be provided on the GitHub repo this week as well.
Yeah, exactly. Like,
Yeah. Excellent. So what's the future for GLiNER, Uzi? Is it multimodal, autonomous driving, AGI? What's in the future for GLiNER?
yeah, I told Ash, the co-founder of Fasino, that my goal is that GLiNER 10 will be AGI.
Let's
Yeah.
do it. Let's
Yeah,
do
we
it.
have a long path for that, but yeah, for now, my short-term objective is to add more and more tasks to it to make like an octopus. You know, for many tasks that does not require like big reasoning, people will use GLiNER as a default. That's like my goal. Like people for classification or any other like, for instance, retrieval, ranking, or even like LLM as a judge, but using GLiNER. So adding more and more tasks so that it became a standard in the small language model field.
Well, it's been amazing watching you innovate, and it's been great working with you for the last 2 years, Uzi, and
Yeah.
seeing your contribution to the open source community. Thanks so much, man.
Yeah,
It's been
thank you,
amazing.
man.
Thanks, Uzi.
Thank you.
Yeah.